Hello everyone and welcome to this session. I'm sorry we are a bit late and I see most of you have already joined. Let me just go back and go through the chat who all have joined. Raj is there, Raghav is already there, Pawan and Vicky are there. All right. Okay. So before I start off with the session, for those of you who have joined the session last time, you are aware that there will be a quiz at the end of the session. The quiz link will be given on the chat window at the end of the session that you can go ahead and take, and the quiz topic would be exactly similar to what we are discussing in the session today. So the session will, I think, help you go about the quiz more easily. For those of you who are new, please don't forget to check the quiz. It will help you kind of get an idea of what kind of questions around these topics will be there in interviews or otherwise written exams as well. Okay. Greetings, Raghav. I hope you all are doing good. Your preparations are going great. And so last we discussed about operators and how operators work in our program, how these operators are manipulated by interviewers and the tricks and tips around those, how to work around to get through the right answers. So that was that. Now if you talk about, today we are going to talk about OOPS. Now OOPS Java, if you're working on Java, OOPS is a very basic concept and it's always asked, no matter which interview you are going to. It's your first interview or it's your 10th interview or it's your 20th interview. If you're going for a Java interview, there will always be a question thrown around OOPS. Now since it's just about testing how good your knowledge of Java is, the basics of Java is, it's mostly theory. So they just want to understand that you are clear with the concepts of OOPS, because the pillars of the Java are formed around these OOPS concepts. So if you have strong knowledge of what this concept is and what that concept is, you can use maybe 2 or 3 or 4 of those concepts combined in the program to get your thing going. All right. But if you're not even aware of the concept, you're actually losing on one very important thing, and that will affect your performance in the company. So these concepts are really important to understand, and you should be exactly aware of what is the right meaning of which word. So we'll go through all the definitions one by one, take a look at a few questions, and then you can go to the quiz where we'll actually ask you the implementation questions around these topics. So if there is a polymorphism question, you will have a few classes, 1 class or 2 class, and then you'll be asked how polymorphism is working around this, what will be the output, what will be printed, and that will test your understanding of polymorphism. Or a program could be there that tests your understanding of function overloading or function overriding. All right, so go through the quiz and let us know the feedback on the quiz as well. You'll get the answers to the quiz once you have attempted. You will get the answers on your mail IDs. So just revert back if you have any doubts and queries on the quiz as well. You can revert back on the mail IDs given. All right. So, okay. I see many of you have joined already. So I'll start off with the session. Starting off with a very basic question, that is the first off question. What do you understand by OOPS? Now, you might have read the definition, and there are multiple definitions around of the concept, but when you are defining OOPS, what is object oriented programming, there are a few keywords that you should specifically mention while defining this whole big world. So these keywords are like the core of object oriented programming. So if you say these things in your definition, that means your concepts are clear. Might not be, but still, if these keywords are there, that means you are aware of what actually you are talking about. Okay, so let me share the screen. All right. So what is OOPS? Three things that you need to remember when you're talking about OOPS: real world objects, states and behavior, and objects and data. Okay, so what do you mean by real world objects? The programming languages before Java worked on functional programming or procedural programming or structural programming. Java brought the concept of OOPS, wherein you are not talking about the structure of a program, you are not talking about how the program functions, you are talking about that the program revolves around your objects. All right, real world objects, simulated to real world objects. So if you have a car around which you have to program, you will create a car class, and then you will create a car object that will work around the car. So Java is based on real world simulation. If you have a bicycle, let's say, so you create a two-wheeler cycle maybe, and then you create a subclass that is bicycle, or maybe create a subclass that is motorcycle. Okay, so object-oriented programming focuses on real world objects. The second thing that is there is state and behavior. So in object-oriented programming, you focus on the state and behavior of the class or the real world object that you are talking about. So let's say, for example, I quoted car. So in car, the state could be tires, the number of tires in the car, the number of seats in the car, the number of rear view mirrors, or etc, etc. There could be multiple state, so that define what is the current state of the object. Then there can be behavior. What is the speed of the car? What is the acceleration? What is etc, etc. So the behavior of the car goes into that. Okay, and then we have objects and data. The third thing to mention in your OOPS definition. So we have objects that revolve around the data. Okay, so let's say you have a class, you have data members, you have functions that work on those data members. Now when you create an object of this class, you know that this object can operate on those data members through the functions. So if the data members are private, you go through the functions to manipulate those data members. So that object and data part is also an essential and important point that should not be missed out from your object-oriented programming definition. So that is the first and the foremost thing that you should be very clear about: real world objects, state and behavior, and objects and data. Now moving on, we'll take a look at what are the different object-oriented programming concepts that we need to be aware of. So starting off with abstraction. All right, okay, at any point of time, if you guys have any questions related to any of the stuff, that any of the definition that I'm talking about, please shoot on the chat box, because I'm watching the chat box constantly. Okay, so all right, Vivek, are you a computer science background? Have you any understanding of Java? Have you read about Java before, or this is your first Java class? Let me know. Meanwhile, I'll move on to abstraction. Now abstraction is one of the very strong concept of object-oriented programming. Okay, what do we mean by abstraction? So abstraction means that when you are talking about an object, let's say we are talking about a car, we'll only talk about the relevant details, like what is the speed of the car, what is the seating space of the car, it's 4-seater, it's a 7-seater, etc. Let's say what is the acceleration, let's say we talk about. We don't go ahead and talk about the mechanics of the car. So what is the processing that went behind preparation of this car? What is the material that is used in preparing the tires of this car? What is the, let's say, seats material, etc. All those details we abstract from the user and just focus on the relevant details that a user might require. Okay, that is called abstraction. Okay, all right, Vivek, I see that you need basics. Okay, this is kind of the basic of Java. It is a very fundamental part of Java that we are talking about here in this session. But other than that, if you have to understand Java from the basics, you can go to the YouTube channel wherein we have a Java for Beginner channel, and you can start off from there. So this you can go ahead. This is the concept part from which the interview questions are generally asked around OOPS. But if you want to understand Java in more depth and in more detail from the very beginning, you can go to the YouTube channel where we have this Java for Beginner series. In that you can start off from the very first video where we tell you how to install Java to work on Java, how to install the IDE, how to work on the IDE, which Eclipse I think we are using there. So what shortcuts are there, etc, etc. So step by step, operators, variables, data types, step by step we are going there. And at any point of time, if you have any doubts related to that, you can post on the comments on those YouTube videos only, and you'll get the answers of your questions. Okay, so about this session, this is about OOPS, a very basic fundamental part of Java. So you can sit through the session and try to listen to what all we are talking about. I hope you get most of it, but even if not, you'll at least get the understanding of the major concepts out there. All right, moving back, abstraction. So the property, the concept revolves around the idea that you show only the relevant details and hide the irrelevant details that are not important. Okay, and how do we implement abstraction in Java? We do that by two things. One is we use interfaces, okay, and the other is we use abstract classes. So we use these two concepts, these two properties of Java to do the abstraction. All right. These examples of real world objects we only read in books and videos but can't see any real life implementation. Okay, so you want a real life implementation. Let's say you have to create a class around simulate a match system, let's say IPL match, into a Java program. Okay, so you'll have a database that has all the details of matches. How many bowlers are there, how many batsmen are there, what are the statistics of each batch. That is there in the database. Now if you have to find the relevant data, okay, in this match, what was the highest strike rate, or what was the highest strike rate in this year, or let's say what was the maximum runs that anyone scored from this period of time to this period of time. This functionality, all these functionalities can be done using a Java program on top of your SQL database. And when you write this Java program to access all these details from your database, that is where you will create let's say you create a player class, that talks about the statistics of the player. Then you create a subclass of the player class, let's say batsman. Now the batsman will deal about specific things that are related to the batsman, runs made or whatever the details of batsman. Then the bowlers, how many wickets he took, etc, etc. So batsman and bowler become the two subclasses of the player class, and now you can use your program, you can write functions around to get the details out from your database through these classes. That can be a real life simulation of this abstraction or OOPS concepts in general. And when you get into let's say when you get into different companies, you will see that there are many real life simulations out there which the companies implement using Java to get all these things done. So car is a very basic example that you'll see only in the books, but there are many examples out there. Let's say you have a e-commerce chain. Okay, so you have your inventory that has all the data. We have X number of this that are priced at this, and that needs to be sent to this location from this location, etc, etc. There are so many details around e-commerce. Now on top of all this database sits your Java program that will take care of, okay, someone is adding this product in the cart, check whether there is actually any quantity left of the product or not. Okay, this is a real life simulation of these examples. So you'll get many real life simulations, but yeah, car is a very basic example that is taken in generally in books and online classes that you take off, because it's easy to explain through this, since everyone is aware of what a car looks like, what goes behind, and what a user is aware of, right? Okay, so moving on. Next one, encapsulation. Encapsulation decides the permissions and restrictions for member variable and function. Now let's say we have a class. I'm not giving a name, let's say XYZ. Okay? Now this class would have some member variables. Let's say 1, 2, 3. And it would have some functions that would work on the member variables. Again, let's say 1, 2, 3. Alright, now what encapsulation does is that it helps you decide which of these member variables or which of these functions will be accessible where. Is this member variable accessible in this class? Is this member variable accessible out of this class in, let's say, there is another ABC class? Okay. So if member variable 1 will be available in ABC or not will be decided by encapsulation. How? That is done by the 4 keywords that we have, that is public, private, default, and finally we have protected. So based on which of these keywords you are using in your class variables or functions, depending on that, it is decided that a particular member variable will be accessible in other class or not. It will be accessible in other package or not. It will be accessible in another project or not. Okay, these things define how restricted your member variables and functions are. So let's say if you define member variable 1 as private, it will not be accessible out of its class. Only through the functions is that you can actually go through and manipulate the value. All right. Okay, I got a problem. Fine, Kishore, we'll continue with the session. I know how to code using abstracted interfaces, but I didn't understand how it is used to achieve abstraction. So how is it used to achieve abstraction? Okay. Let me give you a very simple example. Let's say you have a class A, okay? An abstract class A. Now abstract classes don't have method definitions. They just have the method name, and then you implement these interfaces or extend these abstract classes in your base class, and then in the base class you decide what actually you have to implement. All right, so let's say you have, let me take the batsman bowler example again. You have a player base class. All right, in that you might have some function that is relevant to both bowler and batsman, but then you don't know how to work around the function. So in the bowler class, if you extend that player class, you can define in the bowler class how that function works for a bowler. And then in the batsman class, you can override the function and define how it works for a batsman. So that is how you achieve abstraction. You have taken very common details of both player, bowler and batsman in the player class. So that is common to both. That is abstraction. You have abstracted some functionality into the base class, and then when you are extending it to your child classes, you are defining it in more detail. You are giving more dimension to the definition. All right, that is how abstraction is done. Now, so that was about abstraction and encapsulation. I hope both of these are now clear. Abstraction, like I said, works around interface and abstracts, and encapsulation is public, private, default, protected. Now, during interviews, generally people get confused if some question is thrown around either of these two in a crooked way. So don't worry about that. Just keep in your mind that abstraction is interface and abstract classes, and encapsulation is hiding the data that is not required, restricting the data where it's not required. So that is public, private, default, protected. All right. Now moving on. Next one is polymorphism. How many of you are aware of this term polymorphism? I think this is the easiest of all, and it's not confusing at all as such. So polymorphism is simply referred to as many forms. So if you see the meaning, it just means many forms. That means if you have a function in class A and you override it in class B, so same function A can have a different set of activities here, right? So one function with the same name A can take different values in different classes. So one function can have multiple forms is what is polymorphism basically. Pretty simple. A function, a variable, etc., etc. So one thing that can take many forms is polymorphism. Okay. Now moving on to the next, inheritance. Now what is inheritance? Inheritance is, in layman term, you inherit something from your parents or grandparents or etc., your inheritance. Exact same meaning applies to Java for the word inheritance. When the base class inherits the state and properties of the parent class. So let's say there is a class A and then the class B is extending this. So it will get the data members as well as the functions of class A. So class B is essentially inheriting these values. Now which of these values will be inherited and which will not be inherited will be decided by encapsulation. If some data member is private, whether it will be inherited, it will be not inherited, all those things work around in conjunction. Okay. All right. If I use abstract class, then I have to define all abstract functions in derived class, while in interface I can only define the function which is needed in derived class. That is not true in both the cases. If you are extending a abstract class or if you are implementing an interface, either way you have to define all the functions that are there in the classes. The only difference is, if let's say you have a class A that has F1 and F2, okay, which is extended by B, let's say again F1 and F2, and let's say this is an interface. Okay, now ideally you have to define both these functions, give the definition of both these functions in class B. But if this class B is further extended down in C, you can skip a definition, but then finally you have to give the definition here in class C. So let's say if you give F2 here only, you'll have to give F1 here. That is the only one catch that is there. But yeah, if there are three functions in an interface, you have to give the definition to all the three functions. Okay. Now where were we? Yeah. So moving on, inheritance is simply this: you inherit the values. Now if you extend another C will get the values from both A as well as the new values that are derived or declared in the B. So C will inherit from both. So as far as the chain goes, the inheritance chain also continues. All right. Moving on. Now we'll take a look at, since we have gone through the four basics, let's take a look at the diamond problem. How many of you are aware of the diamond problem? Has anyone came across this before? This is a very fond question in interviews, especially not in written exams but in interviews. Are you aware of the diamond problem? How does Java deal with the diamond problem? Any ideas? real life example of polymorphism. Okay, polymorphism, let's say, try to think. Polymorphism means many forms. So what are the real life examples in which you have multiple forms? Let's say if you give a class named vehicle, okay, it moves from one place to another, it has some basic properties. Now you can go ahead and give multiple forms to the functions when you give a subclass. Let's say car, a four-wheeler, let's say you give, then car, truck, etc. And then those functions can have different forms. For a car it can be different, for a truck it can be different, for let's say any other kind of four-wheeler it will be different. Or if you do a two-wheeler, then you have a bicycle, you have a motorcycle. So all these things can have different forms of the same function. Let's say you have to calculate speed, or you have to do some other calculations around those. Anything that can have multiple forms. So abstract the details and think of the multiple forms that it can take. So if you think of car, you won't be able to think of multiple forms maybe, but if you think of a four-wheeler, you can think of multiple forms. Can be a car, can be a truck, etc., etc. Okay. All right, and moving back now to the diamond problem. So let's say you have a class called A and you have two subclasses B and C. Now both of these classes, let's say, inherit from A. Okay, and finally we have another class D, and this D class inherits from both B and C. All right, this is what constitutes your diamond problem basic case. Now what could be the probable problem in this situation? If you implement a situation like this in your Java program, what can go wrong? Think of what can go wrong in this case. Let's say you have a function f1 in class A, okay, which is implemented in class A, and then you are overloading it in class B and C. Since you're inheriting, let's say you are overloading it. So f1 gets some more lines here, and f1 gets some different set of lines in class C. Okay, so far so good. If you create an object of class B, you know this function will be called. If you create an object of class C, this function will be called, and if you create an object of class A, this f1 will be called. All right. Now further, if you create an object of class D and you haven't defined, overloaded the f1 function in class D, but you are calling the f1 function from the object of class D, which f1 should D class refer to? Should it refer to this, or should it refer to this? That is the diamond problem, and that is the reason why Java doesn't support multiple inheritance. Okay, so if someone asks you if Java supports multiple inheritance, you can clearly say no. So Java is not supporting multiple inheritance, and this is the reason why. So it can be asked other way around also, multiple inheritance supported in Java, then you can code the diamond problem, or if you are asked about the diamond problem, then you can go back to this. And ideally there aren't logically very many cases where this kind of situation needs to be implemented. If there are, then to do all those cases we use object associations in Java. That is how we achieve, if we have to achieve such kind of combination, by using object association. Okay, multi-label, multiple hybrid. Okay, there are many type of inheritances that you can go on, but this diamond formation is what is the diamond problem that is most frequently asked in the interviews. All right, now static versus dynamic binding. There are many other names given to both static binding and dynamic binding, which I think most of you might be aware of, but static dynamic binding is how the questions are asked generally. Okay, anyone, any clues on what static and dynamic binding is? give me some very basic one-liners. Since you're typing, just give me one-liners about what you know about static, or what is the other name you think is given to static binding or dynamic binding, which is very common. I'm sure since you all have, most of you at least have studied Java, you should be aware of static and dynamic binding. No one? Alright, I'll give you a clue. Static binding is also known as early binding, and dynamic binding is also known as late binding. This is another analogy that is given to static and dynamic binding. Alright, now I'm getting the answers. Apple says method overloading, method overriding. Yes, that is the very common name that most of students are aware of. Overloading and overriding. Static binding means objects are made at compile time. Static is compile time, whereas dynamic is runtime. Yeah, that is another thing. So static is runtime. Static is compile time and dynamic is runtime. Since it's dynamic, you can refer it's runtime. Static is compile time, and the other terminology is overloading and overriding. These are the different terminologies on which this difference can be asked to you. What is the difference between compile time and runtime? What is the difference between overloading and overriding? Difference between static versus dynamic. So what is all this about is, you have a class A and a class B, a function f1 here, and B is extending A. So you overload the function here. This is function loading you have defined. So you create an object of class B, you know that you have to call this particular function. So that is compile time. And runtime is when at the runtime of the program, it is decided that which particular function from class A or class B, or let's say if there are more classes in the picture, C is extending A and D is extending B, kind of, let's say this is the situation, and there are functions overridden and overloaded. So the compile time overriding is when the compile time at the runtime, you decide what function would be running. Okay, so remember these names. These are the names that are generally asked for in interviews, because this most of us are aware of. Runtime is overriding, compile time is overloading. But the top two are the names that are asked for, because we generally tend to miss what is static and what is dynamic binding, or what is early binding and what is late binding. Okay, moving on to the next one, association versus dependency. Now these are other core concepts of OOPS. Association versus dependency. How many of you have heard of either one of these, and what do you think they mean? Anyone, any clues? Come on. Alright guys, don't scribble over which questions are going to be asked or not. It's a very nice and easy going session, so you can ask whatever questions you have to ask here and focus on the slides. Now anyone, can you tell me association, dependency, either one of these, if you are aware of either one of these terms? Alright, so association is what we refer to as relation between two objects with multiplicity. Okay, if there are, let's say, two objects of class A and class B, what would be the relation, if at all there is a relation between two classes? That is known as association. Okay, and dependency is when one class uses another at some point of time, and hence it is dependent. Let's say class B, for it to work, you need the variable or the data member or the object of class A. Then class B becomes dependent on class A for its work. That is known as dependency. Alright. So there are many cases when you have a class B and you are declaring the, let's say, data members, and one of the data member could be the object of class A. So let's say we have an integer value and we have a float value and we have a class A object here in class B. Now for any object of class B to actually work, the object of class A should be in place. That means B class is now dependent for class A. This is simple dependency. And association is what is the relation between the two objects of class A and class B. Okay? This is very basic. Now association and dependency, I'll give you another example. So association could be just that a class A has a function of class B or a data member of class B. But dependency would be when a class A, there is, let's say, some function of class A. Okay, or let's say there is a function of class B and the parameters that are passed to this function have an object of class A, or inside the function we need object of class A to make this class B function work. So this becomes dependency. Alright, association and dependency are again asked like this only. What do you know about you? They'll not ask you what is association, or they'll not ask you what is dependency. They want to know if you understand the difference between association and dependency, in which cases association would work, in which cases dependency would work. Okay. Next one, composition versus aggregation. This I'm pretty sure you might have heard of. At least one of these you should have heard of. Aggregation and composition. Now one is a strong form of another. Come on quickly, anyone? Yes, no, yes, no. If someone knows, give me the answer. If someone doesn't, let me know. I'll go through with the session. Okay, Arindam, the previous one that you're talking about, I guess. Association versus dependency. Am I right, Arindam? I think so. Okay, I'll quickly repeat this association dependency for you. Dependency is, let me just clear it up for you. So let's say you have a class A, okay, and a class B. You create an object of class A and you create an object of class B. Now association is if in any way this object is related to this object. Okay, there is any relation, has a, let's say the class A has a data member of class B. Okay, then these two are associated. A has a B, there is a has a relation, right? And dependency is when, let's say, you have class B and let's say there is a function in class B wherein you are using the object of class A as, let's say, input parameter, or you are using the object of class A inside the function. Now for this function to work, you need the object of class A. So B class becomes dependent on A because of this. That is dependency. Okay, moving on. I think got some answers for composition aggregation. Aggregation means usage of one class object in another. Okay, composition is inheritance, Aggregation defines an entity and composition defines functionality. Okay, that is an interesting answer, Kunal. So again, moving on to aggregation and composition has a relation, right? One of you, I think Raghav mentioned, yes, Raghav mentioned has a relation. So aggregation is essentially has a relation. So let's say, let me give you one is a relation example first. Let's say there is a class C and then there is a class B. B is extending C. So we say that B is a C. Now let's say A class extends B. So A is a B and A is also a C since it is in the same chain. That is how is a relation works. Now in aggregation, that is has a, what happens, a class A has B. So this is essentially the pictorial representation for has a. I hope this pictorial representation makes it more easy for you to understand. Alright, that is aggregation. And what is composition? Where a part cannot exist without the whole. That is composition. It's kind of is a stronger version of aggregation itself. There is not any difference, they are essentially the same, but composition is a strong form of aggregation. So in aggregation, A can exist maybe even without B, but in composition, B cannot exist without A. So the part that is there cannot exist without the whole entity. That becomes composition. So I think, Kunal, I think you'll be able to relate to this since your definition was kind of on the point that it's an entity and functionality. Okay. So finally, we are moving on to, since we have discussed almost all the OOPS concepts, the terminologies that are there from abstraction, encapsulation, polymorphism, inheritance, we have seen the is a, has a, we have seen bindings, early binding, late binding, dynamic binding, static binding, we have seen association, we have seen dependency, we have seen aggregation, composition. These are essentially all the terms that are there to a basic OOPS concept. So when you talk about OOPS, this is all that there is. Now if there is a written exam and there is a question on any of these terminologies, let's say method overloading, there is a question. So you will be given a class A, you will be given a class B, and there will be two methods. And let's say they'll create an object of class B and then they'll ask you, so if I now create the object of class B, which function will be called? So that is essentially a overloading example that is out there in front of you on the question paper. So if you understand the concept nicely, you'll be able to actually think in your head where the answer is going to be. Okay. Or let's say, for example, if you might have abstraction question. So there are two classes, there are two interfaces, there are two abstract classes, there are child classes. Now finally, if we create the object of this XYZ class, which inheritance, which function, where it's going to be, kind of questions. Okay, you'll get a flavor of these interview questions or mostly written exam questions in the quiz. So you go ahead and attempt the quiz. You'll get what kind of these programming questions would be generally asked in the written exams. So coming back to the slide, we'll show you a few quick simple examples of how these questions around OOPS can be asked. Okay. Yeah. Can I say composition is dependency? Composition is not actually dependency. Both are kind of different. Dependency is when one doesn't exist. Okay, ideally both have the same formulation that one cannot exist without other, but still there is a difference. What you can do, Arindam, is go ahead and write a program, create two classes, and manipulate your variables and functions, and check when can you create a composition and when can you create a dependency. When you do it live by yourself in a program, then you will be able to, I think, better grasp or understand the difference between the two. Okay, just go ahead, create 3-4 classes, maybe one abstract, maybe create one interface, extend, do play around with these concepts to get a better understanding of how they work. All right. Okay, given a class named student, which of the following is a valid constructor declaration? So constructors again are also part of OOPS. Now I'm sure you are aware of what a constructor does. Which one of these is a valid constructor declaration? 1, 2, 3, 4, 5. Check your options nicely, because most of the time all these options are almost correct. They are trying to trick you in one way or other to get the right answer. So make sure you take a good look at all the options. I have got one answer from Apil and one from Raj. Anybody else? Kunal says 3. Private final student. Okay. Kunal, constructors have no return type. So private, protected, or whatever, any return type cannot be there. If there is a return type, it's not a constructor. So third is not an option since it has a return type. Even void is a return type. So fourth is also not an option. Ashutosh. Return type, if there is, it's not a constructor. Which of the following is a valid constructor? Amit, I think you need to get a better grasp of your concepts. Constructor is a very basic concept. You should be aware of which is valid. This is a very simple question. 2 is the answer. Student, student. Okay, 2 is again not the answer. Also, along with the return type, these constructors cannot also have keywords like final and static. That again takes off the point of the function being a constructor. So since you eliminated all these options because it cannot have a return type, it cannot have final, static, etc., you are left with the first option. So first is the right answer. Next, which statement is true regarding an object? So again, the options are kind of placed close around to the actual definition of object, so make sure you read it with a clear head. Object is what classes instantiated are from. An object is an instance of a class. An object is a variable. It's a reference to an attribute, or it is not an instance of a class. Which one of these is correct? Very simple definition, I think everybody knows. All you need to do is make sure that you have got the correct statement and you don't even need to read the rest. 2 NBN. Yeah, so you all are aware of this. An object is an instance of a class. So this is your right answer. The wrapping up of data and functions into a single unit is called. So now instead of asking you the definition of a concept, this question is giving you the definition and asking you which concept this refers to. Wrapping of data and functions into a single unit, what is it called? encapsulation, abstraction, all these things we have just discussed. Data hiding, polymorphism, message passing. Message passing is nothing but transferring of data from one function to another. It's a fairly simple concept. AAA, I'm getting multiple A's. Why not abstraction? I think I made it pretty clear for you guys to say any other answer now. All right, A is the answer, encapsulation. So when you wrap your data and functions, into a single unit, you are encapsulating. Okay, so that's it for this video, guys. Now make sure that you check out the quiz. There will be questions around, and if you have any questions around this session, please shoot right now before I close off the session. Last time I had several questions around English. I think you are going on the right track there. If there are any more doubts on your English, I can help you with that too. And also, guys, next session, whatever topic you want to take up, if there is any particular topic that you are interested to take up, or if there is any question that you want me to take up in this session, you can leave those also in the comment section. All right. So quiz, I think for those of you who are joining today, if you want to take the quiz, the link will be given. Just click on the link, and you have to enter, I guess, your email ID and name and a few details there, and you will get a set of questions which you can attempt and mark the right answer. So they have multiple choice questions. If you know the right answer, you will have to go through the program, solve the program, get the answers, mark the right option, and once you are done that, submit your survey, and we'll evaluate your answers and give you the right answers back to your email IDs. All right. Okay, so I'm getting a few project ideas. What kind of project ideas are you referring to? Is it like college final project ideas? And then Apple has collections in Java. Okay, I'll make sure I'll talk about collections. Next session, I think it's on 7th of next month. I'm not very sure, but you can watch out the channel. The date will come up on the channel pretty soon, so you are aware well in advance when the session is coming. It will be Friday, I think 7th is the Friday, so most probably then we'll have the next IT session. Please discuss about Android topic. Arindam, actually Android, most of the students might not be familiar with, so for them Android might be a bit over the top. We try to keep these sessions so that most of you can benefit from these sessions. So if you have any specific queries around Android topic, you can maybe drop a mail to our email IDs and we can take up your doubts there. Thank you, Geeta, so much, and I hope your preparation is going well. Okay, so since you guys don't have any other questions, I hope your preparation is going well. I'll make sure I'll take collections in the next or next to next session. And again, don't forget to take the quiz. It will be very helpful for you to actually analyze if you have the right understanding of all these concepts that we discussed here. Okay, thank you so much, guys. College project ideas. Yeah, Raj, I'll try to give you some college project ideas in the next session. Oh, most of you are in final year then, planning for your projects. Cool. Pointer in C. Pointer in C is not most often asked in interviews these days because pointers are kind of gone out the window. There is more trouble using pointers than actually they are useful for, and there are several other methods in which you can implement the functionalities that are given by pointers. So yeah, but still, if I take any C class, I'll make sure that I'll take pointers. Alright guys, so I'll sign off now. Collections, pointers I'll keep in mind, and project ideas I'll try to share with you. You can check out the channel for the next date of the session, and yeah, check out the link, survey link for the quiz as well. Bye bye, have a nice evening.